So how does the system work? So I talked a lot about modularity and that these gas modules, they work in pairs. These are coming, these come now at the moment in containerized systems. So you can imagine that you are inside a containerized system. There's a corridor and you are looking on one side, and to the front of you, you have three sections you're seeing here. Every section is kind of an independent electrolysis unit. It has 15 pairs of modules with electronics, liquid circulation and cooling, which is uh, under, and it's not visible in the picture, but basically every system here is air cooled. So there's fans blowing from below. It goes through a heat exchanger. It cools the liquid and goes out at the top. So every building block is standardized. So this is basically the same design. These are in blocks of 150 kilowatts, and they are tapping from the same DC bus bar, basically. So in one container, you can have on one side four of these, and on the other side another four. That makes it a total number of eight sections, which is around 1.2 megawatts nominal capacity. And the nice thing is, because of modularity and the independent balance of plant that every one of them have, you can run each module depending on the power available you have. So if there is, let's say, only 150 kilowatts available, one module will be operating. And if there is up to 300 kilowatt, then you're operating that. So it's important to know that even within the modules, every single pair can be operated independently. So this kind of modulation allows you to really scale the system up and down within few seconds. So I'm showing this from now outside. So on the right hand side, this is the containerized system, and where you saw the gas modules happening. You see the air filters here for the ventilation system. On the left hand side, you have the power and control module, where we have the DC connection coming in from solar panels, or if we have AC connection, we have rectifiers from either the wind or AC source. And by the way, we can mix the power sources, so we can use DC only. We can also complement DC with grid power, partly, or with wind power. And the nice thing about DC is we can go from 1.2 megawatt to 1.6 megawatt, so we can really go higher because there's no power electronics between our system in between, so we can really ramp up production. The gas module is coming from the storage is coming from biogas industry a little bit. It's meant for a buffer to store hydrogen, use it as a buffer for compression step, or just temporary storage. So for example, this one is around 400 cubic meter, which is around 32 kilograms of hydrogen, atmospheric storage. And also, this kind of storage units come in different sizes. So these are kind of intermittent hydrogen buffering. So the hydrogen that we produce atmospheric is around 2.5 grade. That's 99.5% minimum pure. But for fuel cell applications, or for any application that you need ultra pure hydrogen, we offer hydrogen purity at 99.999% pure. That is 5.0 grade. And this is outlet pressure of maximum 13 bar G. So this comes in addition, as I mentioned, because we want to separate atmospheric applications from pressurized applications. And this modularity comes in layers. So if we are now zooming out a little bit. So when we started at a cell or a stack, we saw a collection of them. And now inside, you have this helicopter view of these gas modules inside the containerized system. And now we are kind of stacking them to build up capacity. So we have the power and control module, gas production modules, and maybe there are some hydrogen storage modules, either coming numbers or different sizes, and they can be compressed. So in this way, we can really scale it without really engineering things from the beginning. So the advantage is that you have a solution for decentralized systems. You can scale this at the speed that you are comfortable with as a business, because adding another module or adding more capacity doesn't mean new engineering and project procurement. It doesn't require, because everything is standardized, like adding Lego blocks.